Hey there, everybody. So what we're going to look at today is we're going to look at partial fractions. Now, I'm going to start with something that we are familiar with and then work and reverse it into partial fraction decomposition. So let's take a look at these two rational functions and let's see how we add those together. Okay. So if you recall, when we are adding two fractions, we need a common denominator, preferably the least common denominator. I picked something pretty simple here just to illustrate the point. I take a look at this denominator, it has an x minus 3, this one has an x plus 2. I know our least common denominator needs an x minus 3 and an x plus 2. So I multiply this fraction by x plus 2 over x plus 2, and I multiply this fraction by x minus 3 over x minus 3. Now taking a look, they both have the same denominator now. So let's distribute this 2 on the top. And this minus 1 in the numerator here. Now that they have the same denominator, we can add those together. So let's take a look at our numerators. We have a 2x plus a negative x, which is just x. We have a 4 plus a 3, which is 7. And there we go. We just added those two fractions together, and we get x plus 7 over x plus 2x minus 3. What we're going to be doing with partial fraction decomposition is we're actually going to be going backwards. Okay? We're going to start with a fraction like this, x plus 7 over x squared minus x minus 6, okay? Which, take a look at that. If I multiply that out, this is the same one we just did. And let's get back to splitting it up, decomposing it. That means we're going to break it down into different parts here, and we prefer if the denominators are just these linear factors. So how do we do that? Now, very often I like to start a problem with one that I know the answer to. So let's actually start with this and let's see how we could come up with that. So the first thing that we would want to do is we would want to factor that denominator. We still have an x plus 7 in the numerator. Now that denominator is going to factor to be an x plus 2, x minus 3. Now when we do partial fraction decomposition, okay, we are going to be splitting it here into two different fractions, one for each of the linear terms in the denominator. Now some other things are going to happen there, but we'll get to that. So we're going to put an x plus 2 there, and we're going to put an x minus 3 there. We need to figure out what goes in the numerators. We don't know what they are, so let's just call this numerator A and that numerator B, and we'll find out. Okay, so we need to solve this for A and B. Now, what we want to do here is we want to get rid of these denominators. Okay, we don't really like working with fractions and equations, so let's get rid of them. So how are we going to do that? We're going to multiply by the LCD. We're going to multiply by x plus 2, x minus 3, x plus 2, x minus 3. Now, on the left side of our equal sign, that just gives us x plus 7. On the right side, we need to distribute. So we're going to have a over x plus 2 times x plus 2, x minus 3. That's going in there. Now notice the x plus 2's will cancel when we distribute, leaving us with a times x minus 3. Plus, now distribute it into this term. b over x minus 3 times x plus 2, x minus 3. Notice the x minus 3's cancel, leaving us with b times x plus 2. All right, so how does that help me? Well, let's continue to work with this right side. Okay. Left side, still x plus 7. Right side, ax minus 3a plus bx plus 2b. Now, we do have some like terms here. Notice these are x terms, and those are x terms. We really have a plus b x's, right? I mean, if I switch these out to numbers, if this was a 3 and that was a 5, we'd have 8 x's. We'd have 3 plus 5, which is 8 x's. Well, they're not a 3 and a 5. They're an a and a b. Okay, so we have a plus b x's. Then we have, I'm going to write this as plus negative 3a plus 2b. These are that's our constant term. There are no x's. There aren't any variables in there. So we're going to group those together. Now, how is that helpful here? Well, compare the right side to the left side. Let me move this to a new page here. Okay. Here's what I notice. I notice we have one x there. How many x's do we have on the right side? We have a plus b x's. So I know 1 equals a plus b. Then I look here. I see the 7 there. Okay? And I see a negative 3a plus 2b. There are no x's in either of those terms. 7 is a constant. Negative 3a plus 2b is a constant. Okay? They must be equal to each other, so we have 7 equals negative 3a plus 2b. And we see from that we have a system of equations. 2 variables, 2 equations, we can solve this. And that's what this unit has been all about, right? Systems of equations. So now we can solve this. We can use elimination, we can use substitution, whatever you guys are comfortable with. I'm thinking here that I want to go with elimination. I'm going to multiply this top equation by 3. 3 equals 3a plus 3b. Let's slide this one right underneath it. 7 equals negative 3a plus 2b. Add those together. 10 equals, a's are now eliminated, 5b. So b is 2. Now looking back at this equation, if b is 2, what does a have to be? 1 equals a plus 2. So a would have to equal what? Negative 1? Oops, I wrote a b there. Negative 1 plus 2 is 1. And there we have it. Okay. What did we start with? We started with this. Okay. Notice that left side works all the way through. We broke it into this equals a over x plus 2 plus b over x minus 3. So we have x plus 7 over x squared minus x minus 6 equals, then we split it into a over x plus 2 plus b over x minus 3, but now we know what a and b are. A is negative 1 and b is 2. Now remember, we said I picked this one because we know what the answer was. Okay? And look back. Isn't that what we started with? We had a 2 over an x minus 3 and a negative 1 over an x plus 2. And that's how we get back to that. So this process is called partial fraction decomposition. We take this, we want to break it down into as simplest of fractions as we can. We prefer the denominators to be linear factors. Now that won't always happen, but we'll be fine. Now, what is the use of this? Why is this nice? Well, this is nice because there will be times where, particularly in calculus, where, well, we'll want to do this. We'll want to take something a little more complicated, break it down. It's in our integration techniques, stuff there in calculus. So there are uses for this, and we see that we need to be able to solve systems of equations to do that. All right, let's look at another one here. 3x over x plus 2x minus 1. Well, the first thing I said is that we have to factor the denominator. This one is already factored, so we're one step ahead of the game. Now we're going to split it into the two different fractions, one with a denominator of x plus 2, one with a denominator of x minus 1. Now, we don't know what the numerators are. Let's call them A and B. So, what's my next step after I write that? Well, we want to clear out the denominators. We want just as simple as an equation as we can with no denominators. So we're going to multiply by x plus 2, x minus 1 on both the left and the right. My new left equation is 3x. On the right, let's distribute. A over x plus 2 times x plus 2, x minus 1. X plus 2's are canceled. That leaves us a times x minus 1. Plus, distribute it to this term. The x minus 1's would cancel. That's b times x plus 2. Let's distribute the a. And let's distribute the b. Now, well, we do have some like terms. How many x terms do I have? I have a plus b x terms. And what do I have for constants? I'm going to write plus. I like writing this in parentheses. We have a negative a plus 2b as our constant. Now, what do we learn from this? Well, take a look at the left side. There are 3 x's. How many x's are on the right? A plus b. So we know 3 equals a plus b. Now, what about our constant term? If we look back at the last example, we said negative 3a plus 2b had to equal 7. Those were the constant terms. Well, here's our constant term on this side. What's our constant term on that side? And the answer to that is 0. The constant side on this side is 0. So 0 equals negative a plus 2b. And here's my system that we can solve. Let me slide over here. Let's see, what do I want to use to solve this one? Let's solve this one by substitution. Let's take that bottom equation, let's add a on both sides. That gives us a equals 2b. I'm going to substitute that into the top equation right there for that a. So I have 3 equals 2b plus b. 3 equals 3b. B is 1, and if b is 1, a is 2. So we have, and I want you guys to make sure that you've finished with this statement here. Okay. What is your partial fraction decomposition? 3x over x plus 2, x minus 1, equals, we put an x plus 2 there, we put an x minus 1 there. This was our a, this is our b, but we're going to replace the a because we now know that is 2. We can replace the b. We now know that is 1. That is our partial fraction decomposition. Now, looking at my timer here, I don't have enough time to do this, but if you want to check your answer, you can certainly graph the left side of the equation. You can graph the right side of the equation, and you can make sure that they match up. So that's going to wrap up this video. There'll be more videos to come on this partial fraction decomposition technique. Thanks for tuning in.